Diffie and Hellman, the mathematical foundation. Their idea is simple and brilliant. It's based on a concept we are all familiar with, that the same mathematical result can be computed from different set of inputs. Take, for example, 2 times 3 times 5. It's what? 30, right? Now, we can first do 2 times 3 and get 6, and then multiply 6 times 5 and get 30. But we can also first do 3 times 5 and get 15, and then multiply it by 2 and also get 30. So what do we have here? We have 2 ways to compute 30. 6 times 5 and 2 times 15. 2 different set of inputs calculating the same number. That's the foundation of Diffie-Hellman. Alice and Bob, 2 strangers, use 2 different numbers, but end up calculating the same number, which becomes their shared secret that the hackers will not be able to find out what it is. So we hope. That's their foundation. Now, they used a little bit more complicated math, but not much. They use modular arithmetic. In modular arithmetic, you map all the numbers, all the integers, all the natural numbers, you map them to a small set that ranges from 0 to n minus 1, where n is a number that you choose, any number. Can be very small, like 3, 5, 6, or can be 1,000,000 or 1,000,000,000 or whatever. But you choose it. Once you chose n, all the numbers in the world map into 0 to n minus 1. 0, 1, 2, 3, 4, 5, etc. to n minus 1. So, Alice and Bob, in the open, choose a number n. And then they choose another number, call it r, root. There are some conditions that n and r have to subscribe to, but not critical. Let's leave it outside for the moment. They choose 2 numbers, n and r. And now, Alice now picks a number, a natural number. Make it a large number so that it will be very difficult to guess what it is. And that is her secret key. Now, once she picked it, let's call it A, her secret key, she takes the number R and raises it to the power of A. Now, you might say, well, this is very difficult to calculate because R may be a large number, A may be a large number, R to the power of A will be astronomical. But we are dealing with modular arithmetic. So no matter how large R to the power of A is, eventually it maps into a number between 0 and n minus 1. Because that is modular arithmetic. So after it maps, it becomes a number, let's call it x, where x is somewhere between 0 and n minus 1. And we have mathematical tools, procedures, that allow us to calculate x from A, to raise r to the power of A, find x, very easy. But the reverse, and that is key, the reverse is difficult, or at least We think it's difficult. The reverse. Meaning, if I have X, to find out what is the number A, that if I raise R to that A, I get X, that is difficult to do. We call it one-way function because it's easy to compute one way from A to X, very difficult to compute the reverse from X to find A. So, if now Alice sends Bob the number X, Bob will be hard-pressed to find A from X. And so will the hacker. So, giving Bob X preserves A as a secret. We will see in a moment why it is important. Now, Bob will do exactly the same on his part, meaning he will choose a number, let's call it B, randomly, any number, and then he will raise R to the power of B and compute a number as a result. Let's call it Y. And this Y he will communicate to Alice in the open. Alice cannot reverse compute B, Bob's private number, from Y. The same way that Bob could not compute A from X, Alice cannot compute B from Y. So now, Alice has her own private secret, A, and Bob, public key, we call it, Y. And Bob has his private key, B, and what he got from Alice, X. Now, what is it good for? Okay. Now, let's take the same root R and raise it to the power of A times B. If we do this calculation, we end up with a number, let's call it Z. Z is R to the power of A times B. And this number, the same way that we did with 2 times 3 times 5, we can calculate two different ways. We can calculate it R to the power of A, and whatever the result, to raise it to the power of B, or we can do it R to the power of B, and whatever the result, to calculate it to the power of A. And now let's see what we have here. The first way, R to the power of A, and the result to the power of B. Now, R to the power of A, what is it? That is X. Right? And now, we have to raise X to the power of B. Now, let's concentrate on Bob. Can he do it? Yes, he can. Why? Because he has X. Alice sent it to him. And he has B. That's his selection, his private key. So he takes X, which he got from Alice, raises it to the power of B, which is his secret, and calculates Z. Stop. Let's now look at Alice. Alice will do it the other way around. She will take r to the power of b, and whatever the result is, to the power of a. Now r to the power of b is what? That is y. Does Alice have y? Yes, she does, because Bob sent it to her. So she takes y and raises it to the power of a. Does she have a? Yes, that's her secret. And calculates the same z that Bob calculated. Bob with his set of numbers, and Alice with her set of numbers. But both calculated z, which is their shared secret. And a third party that knows X, because it was communicated in the open, and knows Y, because it was communicated in the open, but is unaware neither of A nor of B, cannot calculate Z. And so Z is the shared secret of Alice and Bob. And that is the mathematics. Plain and simple.